Hello, everyone. My name is Puneet Tuteja, and today we will be discussing the IPU utilization and metering for services related to data governance platform, cloud data governance and catalog (CDGC), cloud data marketplace or CDMP, Clear GPT, and data access management. Before we get deeper into the discussion, I would like to clarify that the main motivation behind recording this video is to make customers understand the different meters and examples showing how the corresponding calculation is performed for each meter type. The metering units, tiering, and the IPU per unit values could change or evolve from time to time, and thus refer to the current metering card in the administrator metering tab for the same. So here is the agenda for today's topic for metering and IPU calculation. First, meters contributing towards CDGC, CDMP, Clear GPT, and data access management. Second, understanding each meter type. Third, metric units and IPU calculation parameters. Fourth, IPU charge per metric unit. And the last, examples showing billing cycle metric consumption and IPU calculation. Now, let's talk about the meters contributing towards CDGC, CDMP, Clear GPT, and data access management, IPU consumption. So here you might be using either or all of the below services like the CDGC, CDMP, Clear GPT, and the data access management, and below meters would apply accordingly. For CDGC, it's catalog records, governance records, scanner execution, which is basically the computers, and the metadata record consumption. For CDMP, we have marketplace records. For Clear GPT, it is the Clear GPT queries. And for data access management, the three meters are the data access management policy pushdown, data access management queries, and the data access management rows processed. Let's go one step deeper and understand what each meter means, as we saw in the last slide in little bit more detail here. So catalog records are basically the technical records or the metadata records that are created or ingested into CDGC as part of scanner execution to extract metadata from the source. Configuration of creation and configuring the scanner is performed by the governance administrator in the metadata command center or MCC. Also, if you have created any of the data quality rule occurrences in CDGC or any of the rule occurrences that got created as part of the DQ automation, these rule occurrences created would be counted as catalog records as well. Some of the common technical asset examples could be tables, views, columns, reports, matrices, workbook, worksheet, Tableau dashboard, data quality rule occurrences, and so on, depending upon the source that you are scanning in CDGC. Getting to the governance records, these are created directly in CDGC through user interaction, either through UI or bulk import template utilities or even API. These are the assets that provide the business context or business meaning to the technical assets scanned from various sources in CDGC. This could include both descriptive metadata documented by data governance practitioners, data stewards, and subject matter experts. Below are the governance assets supported in CDGC. AI model, business term, data quality rule template, data set, glossary domain, glossary subdomain, metric, policy, process, system. So the above two meters we discussed are number of records based. Now let's talk about the scanner execution. Scanner execution is the process that enables the extraction, ingestion, and processing of technical metadata that represents the data structure and content of resources, systems, applications, and data stores. Scanner service is the primary means by which the data is brought into the CDGC system. Scanner is invoked through the configuration of a scanner of a source in the metadata command center or MCC. Execution of scanner would consume a number of computers, and the number will be determined based on the configuration parameters of the scanner. This could be either a combination of will operations such as the metadata extraction, data profiling, data quality, data observability, data classification, relationship discovery, glossary association, and connection assignment. Getting next, metadata records consumption. This basically refers to the API calls that are being triggered by either client or application using CDGC API endpoints. These API calls could be just search, export APIs, or API calls that create or delete assets in CDGC. Please note that an API call that searches the catalog may return 0 or maximum of 100 assets per API call. An API call that creates, updates, or deletes may receive one or more assets with maximum limit of 25 assets per API call. Any governance administrator related activities performed via APIs that are performed in the metadata command center, such as catalog source extraction, source maintenance, connection assignment, catalog source scheduling, catalog source job monitoring, are not counted towards API IPU metering. Now for CDMP, let's talk about marketplace records. Marketplace records constitute the assets created in data marketplace either through UI or bulk upload utilities provided by the service. Asset classes supported by data marketplace includes marketplace data collections, marketplace active orders for existing and new data collection requests. Important part to be noted here is that active orders are counted towards the metering for first 30 days from the date of order creation. For Clear GPT, we meter as per Clear GPT queries. Clear GPT is a generative AI powered data management tool to simplify data insights for all. It is a conversational interface for your CDGC and MDM Business 360 dataset discovery, metadata, and data exploration and data transformation for analytics and AI using natural language prompts. Some common examples of Clear GPT queries could be show me catalog sources of type Snowflake, show me all data sets that contain column income. How do I create connection in administrator or find all business entities in customer 360? For data access management policy pushdown records, these are the catalog records or technical data sets stored in CDGC that are returned as part of the data access policy filter created or defined by the data access owner. A simple example could be the data access owner created a data access policy granting read access to HR and finance groups, and the filter returned 100 tables. The common examples to be returned would be tables, views, reports, dashboards, and so on. Coming to the data access management queries meter. This meter would be used in marketplace data access management use cases where queries are submitted through a JDBC driver that handles all API calls to the data access management's data proxy. Here, queries can be submitted using structured query language or the SQL. Important point to be noted here is that the meter would be charged unless the query fails with any syntax error. Next is a data access management rows processed. Number of rows processed invoked by either data access management's data process query or CDI access policy transformation to enforce access management policies. So for CDI, all rows input into a mapping containing data access transformation will be counted towards the meter. For data proxy, it would basically be the number of rows returned depending upon the query. So now we have understood the various meters involved in CDGC, CDMP, Clear GPT, and data access management. Let's look into the metering units, IPU charge per unit, and how the calculation works. For the catalog records that we see, they are metered per 100K records, or metering unit is per 100K. Similar here, we can see that the tier is there are two tiers involved, 0 to 500K and above 500K, and the IPU per unit cost is 0.83 for first tier and 0.067 for the second tier. Similarly, for the governance records, the metering unit is per 10K records. There is no tiering, and the cost is 9.5 IPUs. Marketplace records per 10K records, no tiering, 41.6 IPUs per unit. These three are the per record meters. Now coming to the scanner execution, there the metering unit is hours. So this also has no tiering, and the IPU per unit is 0.32. For the metadata records consumption, it's per 1,000 API calls. There are two tiers involved, 0 to 100K, which is almost free or which is free, and anything above 100K is 0.32 per unit. And then for the Clear GPT queries, it's per 1,000 queries. There is no tiering involved, and IPU per unit is 50. Now, coming to the calculation, as we see for the record-based meters, the records are aggregated uh, on each day basis. Same applies for the governance records and the marketplace records. For the scanner execution, one compute R is equal to individual job running for 1 hour on one logical CPU core, secure agent, machine. For the APIs, it's one API call calculated individually made to an API endpoint, and the Clear GPT is per query basis. Coming to the data access management queries, the metering is per 1,000 API calls for the queries, per million rows for the rows process, and per 100 records for the policy pushdown. We can see that there are two tiers involved here. For the queries, there are 5 tiers involved for the rows process, and there are 4 tiers for the policy pushdown. Similarly, the calculation is based on one API call calculated individually based to an API endpoint. Since this is number of rows, it's number of rows processed, and this is number of records. So it's similar to the catalog records or the governance records. They are aggregated on the each day basis. So this IPU per unit or the tier, this is something all we can see in the administrator metering tab. So here I am logged into my administrator in the metering tab, and I'm going to click on my current rate card. If I scroll this down, here I can see for the scanner execution, it's 0.32 per IPU per unit. This is exactly I was showing before in the deck as well. So getting back to the slides, there are few notes that should be kept in mind, which I sort of covered earlier as well. For the marketplace records, it's the active records only counted as marketplace asset for first 30 days from creation. For the metadata records consumption, for the search and bulk export APIs, the max limit is 100 assets per call. For the import assets API, it updates or deletes, it's the 25 assets per call. And any governance administrator activities that are performed on the MCC, that includes the maintenance, connection assignment, or external scheduling through APIs, they are not counted towards the API metering. For the data access management queries, queries will get charged unless and until it throws a syntax error or it fails with a syntax error. Data access management rows processed. So if the query is cancelled, it will be counted for the number of rows that were processed, and all rows input to a mapping containing data access transformation will be counted towards the meter. Now, since we have covered the basics, it's time to get to the examples of each category of the meter type. Let's start with the catalog records. So here we can see like the governance administrator configured one metadata scanner source to run monthly, and the job completed overnight and ingested 40,000 metadata records. Next is configured two metadata access records. and to run weekly. Job completed overnight and brought 60,000 metadata records each. Weekly run ingests additional 20,000 records for each run. So here, when we see the number of catalog records on day 31, catalog source 1 has 40,000 records, catalog source 2 has 120,000, and catalog source 3 has 120,000 records as well. Now, if once we go to calculate the records day-wise, since the IPU meter or IPU calculation is per day basis, so from day to day 8, we are seeing there are 40,000 records. From day 9 to day 15, it's 160,000 and 200,000 and so on. So one thing that, as I mentioned, like the meter is based on the individual day basis. So that's where we need to count the number of records on each day basis. And this is where we did not exceed the threshold or the second tier of 500K on any of the day. Hence, this tier does not applies. Doing the IPU calculation day-wise, based on each day, we are multiplying with the IPU per unit, and we are calculating the number of IPUs consumed. So these are the IPUs that we have consumed from day 2 to day 8, like this one, and so on. Now we are multiplying with the number of days. So like for day 2 to 8, it was this IPUs and the number of days were 7. So I'm multiplying by 7. Similarly, I have done for the other factors as well, or the other units. And the final consumption for my entire billing cycle is 41.81 IPUs. One important point to be noted here is that if the data quality automation is enabled during the scan and the data quality rule occurrences are generated in that, so how many data quality rule occurrences get generated? Each occurrence will be considered as one catalog record. Getting to the governance records, so data steward created 120 business terms and 10 policies on day 1. On day 7, 12 data sets and 10 policies were created. Day 14, 320 business terms, and day 28, 30 policies were created. So number of governance records on day 31 are 502. Now let's count the number of records day wise. Day 1 to 6 is 130, 7 to 14 is 152, 14 to 27, 472, and so on the 31st day, it's 502. So IPU calculation day-wise is like we have done the calculation similar in the catalog records, like 130 were for first 6 days. Divided by the tiering into the IPU per unit charge. So we have calculated the IPUs that have been consumed, and then we have multiplied with the number of days. So the total governance records consumption for the billing cycle is 9.932 IPUs. So far, we discussed both the record-based meters. Now coming to the scanner execution. So scanner execution runtime options selected are metadata scan, data profiling, and data classification by the governance administrator. So secure agent CPU sizing is 4 logical CPU cores. Time for metadata extraction and profiling is 90 minutes. Number of metadata records extracted is 36,000, and the time took for the data classification is 10 hours. And frequency is every 2 weeks. So compute hours on secure agent for execution of metadata scan and profiling is like, since we had 4 logical CPU cores into 90 minutes, so we took 6 compute hours. For data classification, it's 10 compute hours. So total, it's 16 compute hours. And since it's running bi-weekly, we are having 32 compute hours. For 32 compute hours, we are multiplying with the IPU per unit, which is 10.32, and then the calculation is 10.24 IPUs. So one important thing to be noted here is that secure agent is deployed only for the metadata extraction, data profiling, and data quality. For other operations, such as the data classification, data observability, relationship discovery, and glossary association, no secure agent is required, and thus number of execution hours is same as the number of compute hours in such scenario, which is taken into the calculation. Coming to the metadata records consumption. So user A, B, and C all belong to 3 different roles or personas, where user A is just performing some searches. So we can see that user A invokes CDGC API search catalog, and the catalog returned 950 assets matching to the source condition. User B is a data steward who wants to import assets and into the using APIs, and created 40 policies and updated 200 glossary assets and deleted 10 processes. User C is basically a governance administrator, and he executes APIs from external application to run 2000 catalog sources and performs 8000 connection assignment. So here we see the number of total API calls by respective users is keeping the limits into the mind. So first, since it's the search APIs, keeping the 100 assets per call, it use 10. Similarly, for user B, it's 25 assets per call. It's the 10 API calls, and the user C has 10,000 API calls. So total API calls from the IPU metering is 20 API calls for user A and B. Since the governance, the administration calls are not calculated towards the IPU meter. So as we know that the first 100K API calls are free, practically for this particular example, there is no IPU consumption. Coming to the marketplace records, so here the marketplace collection owner created 5 data collections, and data consumer placed order for 2 of them. On day 2, another consumer placed order for 1 collection, and on day 31, data owner created 5 more collections, and consumer placed order for 2. So count of record devices on day 1, it's the 7 marketplace assets or marketplace records. Day 2 to day 30 is 8. And on day 31, it's 13. Now we see that why it's 31, because 2 open records that were 2 open orders that were on day 1 are no more getting counted as active towards the marketplace meter. So now once we have to do the IPU calculation day wise, similarly to the governance records or the catalog records, it's a 7 by the number of tiering and multiplying by the IPU per unit charge, which is 41.6. So the consumption is 0.029 IPUs and so on. And now the IPU calculation for the billing cycle is 0.029 plus number of days. So the overall consumption is 1.04 IPUs. Coming to the ClearGPT queries, so user A uses 20 queries daily to interact with ClearGPT. User B uses 20 queries per day for data exploration purposes. And user C uses ClearGPT for all the MDM related and the product help queries, which is average of 50 queries each month. So here we are just for the example's sake, we are taking like, let's take there are 22 working days in a month. So the user A is on an average doing 440 queries, user B 550 and user C 50. So total queries for the month is 1040. So again, keeping the tiering as well as the IPU per unit charge, the consumption is 52 IPUs for the billing cycle. Coming to the data access management queries. So here the user connects to the data proxy and issues a single SQL query. This query successfully runs and retrieves the required data set. He submits another query, but the query is rejected due to syntax error. Again, he corrects that query and resubmits it. The query successfully runs, but does not return any data. The user submits one last query. The query tries to perform an operation on the column that he doesn't have access to. On that basis, the query is rejected by the proxy. So here, keeping the considerations into the mind, the total queries we executed were 4, but the queries are get counted towards a meter or 3. Since the second query got rejected as a syntax error, which is something not counted, getting counted towards a meter. So the IPU calculation for the same here is 0.002 IPUs for the billing cycle. Coming to the data access management rows processed. So here user issues a query into the data proxy. The query processed and returned 10,000 rows. He issues another query in the data proxy. This query doesn't process and return any rows. He issues another query, but the query cancels in the midway. So the query processed for 1050 rows and return 1000 rows. And the Data engineer runs a CDI job with data access transformation that retrieves 20,000 rows from data source A and 10,000 from row B. So total rows processed during the data access management data proxy is 11,050. As we know that even if in case of the cancellation, the total number of rows processed are calculated towards the IPU calculation. And the for the CDI, it's 30,000. So total rows processed is 41,050. And then keeping in mind the tiering as well as the IPU per unit charge, the consumption is 0.03 IPUs. Coming to the data access management policy pushdown. So here on day one, data access owner creates data access policy granting read access to HR and finance groups, and the filter returns 100 tables. Then he creates a new policy granting read and write access to the product group. However, the filter returns same 100 tables. So nothing changed here. Now on day three, no policy change, but the classification change happened. Now the policy is returning 80 tables instead of 100. And on day four, data access owner creates a new policy that returns 200 new tables. From day 5 to 31, there are no changes. So now we are calculating the number of records day wise. So on each respective day, we can see the number of records are mentioned here. Now, IPO calculation day-wise is same way we are calculating on each day basis, and then we are calculating the IPUs, and then we are multiplying with the number of days to calculate the IPU consumption for the entire billing cycle, which is 4.93 IPUs for this example. So just to conclude the session, here you can always go to the IDMC administrator metering and current rate card to access the various to the latest rate card examples or the latest values of the rate card. And in the you can always use this link for the measurement guide. This provides the a lot more examples which you can refer for various meters. So as part of this recording, I have just focused on the governance meters. For their examples, you can refer this guide for all the other data integration platform as well as the MDM related meters as well. So we would love to hear back from you. You can provide your feedback at the support videos at informatica.com or this x.com link. Thanks for your time and have a great day ahead.